Welcome to lesson number 8, and this is rational equations part 2. So in this lesson we will solve rational equations which reduce to quadratic equations. Alright, we will also consider equations that have no solutions. Okay, so considering equations with no solutions. Now, to do this lesson you gotta remember how to solve rational equations algebraically. And just recall that if the equation consists of a single rational expression on each side, then you have to cross multiply. If there's more than one, then you have to multiply first by the lowest common multiples of the denominators, and then use your previous skills of factoring and expanding and canceling out like terms, and your permissible value, your non-permissible values, of course. And in that case, you don't want to be able to divide by 0. So if we remember the previous lesson where we had to make the graph of this problem here, you'll remember that we had a value of 0 and 2 that our graph came up with. So in the previous lesson we solved the equation graphically, and the solutions to x were 0 and 2. Now what we want to do is solve this equation algebraically. Now, to do that, remember we need to state our restrictions where x cannot equal, in this case, plus or minus 1. And so we know that those cannot be the solution to our problem. Now, in order to solve this algebraically, remember that we have to multiply by our lowest common multiple. In this case, our lowest common multiple, or our LCM, lowest common multiple, is going to be x plus 1 and x minus 1. Okay, so that's our lowest common multiple, which we have to multiply both sides by. So let's do that right now. X plus 1, x minus 1, and we're going to multiply that by 3 over x plus 1, and we're going to also do the same thing to the next term, x plus 1, x minus 1 times 1 to x minus 1. And that equals 2, and we'll do the same thing over here, x plus 1, x minus 1. Okay, now from here we can cancel out our common factors, x minus 1 and x minus 1, which will leave us with 3 times x minus 1 plus 1 times x plus 1. And this is going to equal, same thing over here, 2x plus 1, x minus 1. From here we need to expand these terms to give us 3x minus 3 plus x plus 1. And that is going to equal, difference of squares would be x squared minus 1 times 2 would be 2x squared minus 2. Right, I have my difference of squares, and then multiply that by 2, and that's what I'll get. And now we need to bring everything to the other side, set this equal to 0. If I do that, remember that I have this, and this term would give me a negative 2. Negative 2 on this side would give me a negative 4. Oh, no, sorry, hold on a second. Negative 2, and I have to add it to this side, so it would cancel that out. Alright, well, here, I'm going to do the long way so I don't get lost here. Okay, so let's add up our like terms first. So negative 1 is negative 3 plus 1 is going to be negative 2. 3x plus x is going to be 4x minus 2. And I have 2x squared over here minus 2. If I want to bring this over to the other side, these are going to cancel out, and then I'm going to be left with 0 is equal to 2x squared minus 4x. If I factor this out, I'm going to have, I can bring the 2x out of both of these, it'll be 2x, x minus 2. And there I have x, 2x and x minus 2, and so I have my x values are equal to 0, or x is equal to positive 2. Okay, so the question we solved algebraically or graphically earlier, we now solved algebraically. Cool. Now, let's look at class example number 2. Consider the rational equation x squared minus 5x minus 6 divided by x plus 1 is equal to 2. So we want to solve this problem by cross multiplying. So I want to cross multiply this term and then this term, but since it's 1, nothing's going to happen. So we're going to have x squared minus 5x minus 6 is equal to 2 times x plus 1, and that's going to leave me with x squared minus 5x minus 6 is equal to 2x plus 2. Alright, if I set this side equal to 0, I'm going to bring my 2x over here, which will leave me with x squared, 2x minus 2x is 0, negative 5x minus 2x would be negative 7x. 2 minus 2 is 0, negative 6 minus 2 is going to be negative 8 is equal to 0. And I can then factor this just by inspection. My factors are going to be x and x. It has to multiply to give me negative 8 and add to give me negative 7. So I'm going to choose positive 1 and negative 8 is equal to 0. So that means that x is equal to negative 1 and x is equal to 8. But let's look at what our non-permissible values were. We said that x cannot equal negative 1 in this case. And we have a value of negative 1. Since this is a non-permissible value, I'm just going to go like that. And so this must be our answer. X is equal to 8. So then why is one of the solutions to the quadratic equation formed in A? How come it does not satisfy the original equation? Well, the reason is x is equal to negative 1. That's a non-permissible value. It's non-permissible. And so if you have a non-permissible value, if you were to plug that into your equation, that's going to lead to a divide by 0. And since if we're dividing by 0, 0 divided by 0 will not equal 2, right? It's a non-determinant. And so if that's the case, then it's actually not possible. So this is one of those equations where you only have one answer, even though your quadratic equation says you have 2. Now let's look at class example number 3. State the non-permissible value and solve the equation algebraically and verify the solutions. So in this case, I have x on the bottom. That means x cannot equal 0. So remember, if I have a rational here and another term on both sides, then before I progress, I have to multiply both sides by x. So x times x plus x times 2x is equal to 3 times x. Okay, now from here, that's going to give me x squared. X and x is going to cancel out, giving me 2, and this is just going to be 3x. Now I got to bring this to the other side. X squared minus 3x plus 2 is equal to 0. Okay, so I balance out my equation, and now I'm left with my quadratic here, and I need to factor this. So x and x. If I look at this, I can factor this by inspection. What two integers multiply to give me 2 and have a sum of negative 3? Well, I'm going to use negative 2 and negative 1 is equal to 0. And so now I know that x is equal to 1 and 2. In this case, I need to verify and see if either one of them are not going to work. So if I plug 1 into here, 1 plus 2 over 1 would just be 1 plus 3. That works. Okay. If I plug 2 into here, 2 plus 2 over 2 would be also 3. So they both work. We're good. Now let's do this question here. Remember, if we have something like this, we can just cross multiply. There's only one term on each side. So we're cross multiplying, but before we do that, we should probably state our restrictions. X can equal, this is a difference of squares, which means that we have x minus 2 and x plus 2, and we have plus 2 here, so x cannot equal plus or minus 2. Okay, so we will begin by, let's expand this first, and then we'll cross multiply. So that's x plus 2 and x minus 2 is equal to 2 times x plus 2. And actually, we don't really need to expand that since we're just cross multiplying anyway, so sorry, that was kind of a waste of time. But anyways, x, since we're cross multiplying these terms, or these terms rather, it's going to be x plus 2 is equal to 2 times x squared, let's use this one, minus 4. Okay, and now we need to expand this, which would give us x squared plus 2x is equal to 2x squared minus 8. Let's bring everything to one side, balance this out. If I subtract x squared from 2x squared, that will just leave me with x squared. If I am subtracting 2x from here, I will have negative 2x, and this 8 is going to just stay as negative 8. Okay, so what I can do now is just factor this. If I factor this, I am going to be left with x and x, and I'm going to have a negative 4 and a positive 2, and that's equal to 0. So I know that x is equal to 4 and negative 2, but remember that we had a non-permissible value here. X can't equal plus or minus 2, so x has to be equal to 4. So we'll reject negative 2 because it's a non-permissible value. Now, last question. Show that the equation 8x plus 10 x minus divided by x minus 3 minus 4 is equal to 10x plus 4 x minus 3, and that this has no solution. All right, so we need to show that this has no solution. Now, if I look at this, remember that if we have a rational equation that has 2 on each side, or 2 on one side and 1 on the other, they're not even, so we have to multiply by our lowest common multiple, in which case it would be x minus 3. And so I have to begin by multiplying both sides by x minus 3. So that's 8x plus 10 times x minus 3 minus 4 times x minus 3. And that's equal to 10x plus 4 over x minus 3 times x minus 3. So these terms are going to cancel out, and we're going to be left with 8x plus 10 minus 4x, if I distribute that, plus 12. And that's equal to 10x plus 4. So let's gather our like terms together now. If I have 8x minus 4x, I'm left with 4x on this side. 10 and positive 12 is going to be plus 22. And I'll have 10x plus 4. Let's bring this 4x over here just so I'm not dealing with a negative x value. And I'm going to have 22 is equal to 6x plus 4, because I subtracted this from this. And then I'll bring this over here. So I need to subtract 4 from 22, giving me 18 is equal to 6x. And if I divide by 6, I get a value of x is equal to 3. Now, the reason this has no solutions is if we look at our restrictions, x cannot equal plus 3. And so, since this is a non-permissible value, x can't equal 3, there's no solution here. It's easy peasy, no solution, because that is a non-permissible value. And that is it for lesson number 8.